Hi there, I am Platon.
I'm design engineer.
Don't do that.
Alright, my name is Platon. I'm a freshman. My major is shipbuilding. I am design engineer in the team. This year I was engaged in the hull design of the AUV and I designed the ROV for May 2019.
Hi, my name is Vitaly and I'm a first year student of computer science and I'm a programmer in the team. My task this year was to make all the designed devices work. Before that, I had already programmed other AUVs and ROVs.
Hi, my name is Alexei. I'm the captain of the team. I'm a 4-year student. My major is computer science. My role on the team is programmer. I came up with strategies for how to use our design features to perform maximum of the tasks. I have previously programmed ROVs and AUVs. We decided to participate in Robosub 2021 only this May. We failed to revive the old vehicle. All the old crew members left, so we didn't have time to learn from them.
So we decided to buy a new AUV and these are our requirements for it. Minimum dimensions, cost up to $2,000, the propulsion system that will allow us to complete all the tasks, good camera and the feasibility of computer vision, the possibility of adding the payload.
We have reviewed a lot of vehicles, but only middle AUV has fitted all these requirements. Currently, this vehicle is one of the smallest AUVs in the world. It also has a fast delivery. Actually, here it is. The weight is only 1 kilogram and dimensions are 250 by 200 by 90 millimeters. This became a serious challenge for us during the development of the payload tools. The main hull subsystems of the vehicle can be distinguished as sealed housing, buoyancy, thrusters and payload. The enclosure and dome are made of acrylic so that you can install two cameras, front and bottom, and watch the LED indication. The back cap and the dome are pulled together with pins, which preserve the integrity of enclosure and make chassis for installing the buoyancy and the tools. The cap has two sealed lead-in for connecting the payload. We made a market dropper on solenoid, a torpedo launcher and manipulator made of a cheap brushed motor. We took an old hydroacoustic system but upgraded to install on a middle AUV. We also realized that all payload tools can be installed on the vehicle, so we decided to use two subs.
Due to epidemiological situation, it was difficult for us to get together and to train in the pool. That's why we had to meet and to test our sub in simulators. For example, we used Minecraft for meetings. You ask, what? Minecraft? Let me just show you everything. As you see, we have fully adapted to online communication. Here we talked, argued, and just had a great time.
Let's get down to business. Our competition strategy consists of assessing our own strengths and weaknesses, analyzing of our own and other teams' experience, using our advantages and particular attention to hull design including payload.
As our vehicles are commercial, we had no problems with the reliability of the hull. This is our strong point, and the weak point is that all payload tools have to be as small and cheaper as possible, because we spent most of the budget on middle AUV. We created and tested the payload using SolidWorks. The main advantage of the market dropper is simplicity and cheapness. As a result, it costs $2, including spent plastic for a 3D printer. The torpedo launcher cost a little more, but still 50 times cheaper than the 2019 version. To design the manipulator, we took the open source Grabber project and redesigned it for underwater use. Total cost $5. Of course, we did not limit ourselves to Minecraft and SolidWorks. To develop the strategy of completing the tasks, taking into account designed payload, we used free simulator of underwater robots.
As you see, this is a very handy software. In addition to programming the sub itself, we can test it at once. Also, this program has simplified 3D constructor. in which it is very easy to work. We can design any obstacle and check how robots cope with the task.
Our strategy takes into account installed on the sub's payload, and all communication between the vehicles is reduced to transmission of the octagon course from the AUV with hydrophones to another one. We carry out this transfer using Bluetooth modules. With this strategy, we can score almost the maximum number of points, and also get bonuses for the sub's weight.
After discussing all our plans, strategies, and testing in simulators, we can confidently return to real life.
Unfortunately, it is impossible to make the hull and payload in the virtual world, and sometimes we had to go out and work in the harsh reality, but we followed all the preventive measures for safe work. Here is our work area. Here we spend most of our time working on the sub. We have in stock machines, soldering irons, a large aquarium, 3D printers, and spare parts.
Certainly, we didn't manage with only aquarium. We tested vehicles in the large pool. We checked the housing waterproof, payload working capacity, and at the same time our software.
We also realized how different the results of the runs in the simulator and in real pool are. We had to correct the code a lot and to check again until it would work. Although our subs were purchased, we spent a lot of effort to prepare for the competition. Constant online meetings, discussions and trainings helped us to cope with many design, programming and other tasks.
Of course, the pandemic has changed a lot in our world, and this competition is no exception. We are grateful to the organizers for such an experience. Take care of yourself, wear a mask, and do not replace the real world with a virtual one.